Okay, so we'll try to understand the definition of the pressure, different types of pressure units, and actually how to use it in real life. So, in general, pressure is a normal force which is exerted by the fluid per unit area. So, just to say a couple of keywords here, it is a normal force which is exerted by a fluid per unit area. So, what does normal means? So, let's say you have a surface, the force is acting this way. So this is the force directions. You can see it makes a 90-degree angle, so we can say this is normal force. Okay, now if we have, this is the fluid particle, let's say this is the fluid particle, so the pressure it could apply from different directions. So it could be like this from this directions, it could be like this directions, it could be like this, or this. So just you need to make sure that it is just applying, it's making a 90-degree angle. So basically Pascal is the unit for pressure, we usually use it. If you can correlate it, we know pressure, this is equal force over area. So the unit for the force, it is Newton, and for the area, this is meter square. So this is Newton per meter square. You see here we say it is Pascal, but in Europe actually they use different types of units, sometimes bar, the standard atmosphere, or kilogram force per square centimeter. So we'll try to understand how this force and the area, surface area, is important for the pressure. Let's say look at this picture here in the right hand side. So here we have the hammer and this is a pin. Let's say this is just a piece of wood, okay, wooden objects. So we want to actually we got this pin. So if you apply the force like this way, you see when it is the pin, we have kind of like, it's like this. So this is the shower phase. So in this case, you look here, the area is so tiny, isn't it? Very small surface area. Here the area is significantly higher than this shower phase. So if you apply the force on this, then you can easily, you see, it will easily enter inside these wooden objects. But if you do the opposite, like if you just apply the force on this sharp edge, and then it will be really hard for you to enter the pin inside this wooden objects. What's the reason? So when you are using, look here, we have more area, so we are applying equal amount of force on more surface area. Here it is very small surface area. So look here, pressure, it is equal F over A. So we will keep this force same, it is 3, we're not changing it. But if we increase the surface area, you see, then when it is 5, it is 0.6, this is pressure. When we will increase the pressure, the area, then you see it's decreasing, the pressure. When it is 7, you see it's decrease, and when it is 8, you see. So less surface area, it means less surface area, it means more pressure, and the high surface area, it means low surface pressure when your force is fixed. We'll try to understand it when we'll solve more problems. Here 3 important definitions: the absolute, gas, and the vacuum pressure. We need this concept throughout the semester, even in the real life, but just note that we will use the absolute pressure. We'll use the absolute pressure always in these subjects, unless it is specified. So here is the chart. You will see the difference and the definitions between this absolute, gas, and the vacuum pressure. So absolute pressure, this is the actual given pressure, okay. The gas pressure, this is the difference between the absolute pressure and the local atmospheric pressure. So it is the absolute pressure and the local atmospheric pressure. Here you can see the definition: gas pressure is absolute pressure and the atmospheric pressure, and the vacuum pressure is, it is the pressure below atmospheric pressure. So basically this is the 3 definitions.